Okay, so we are today, so we're going to take a look at B and C. Right. So you guys can do it all together at the same time. Right. So B, a 3.5 kilogram toy car travels around an 8.3 meter circular track at a constant speed of 3 seconds. What is the centripetal force exerted on the car? What exerts this force? So, where's my clicker? There it is. The clicker. TV remotes used to click, so we got click. We call them clickers. All right. So, what do we know about this situation? So for B, we know the track is 8.3 meters around, right? That is the circumference, right? So 8.3 equals 2 pi r. How do you find r? Divide by 2 pi. Now when you do this in your calculator, make sure you put the 2 pi in parentheses. Yep. Right? What do we get for our radius?
Oh, for our radius?
Yep. 1.3. What else do you know about this car?
It's 3.5.
3.5 kilograms. And has a velocity of 2 meters per second, right? Right? So, which equation should we use to figure out the force exerted on the car? Which equation should we use?
4.
1, 2, 3, or 4? 4? Why 4, Derek?
You got all this. You got all those.
Okay. We have mass, velocity, and radius, right?
Yeah.
So, F equals mv squared over r. Now we could use this to find acceleration and plug in the 3, but this works too. So F equals 3.5 times v, v squared, sorry, over r. So 3.5 times 2 squared over 1.3. 3.5 times 4 over 1.3, right? What does that end up equaling?
10. I got 10.6.
Well, like 14 over 1.3. What'd you get? 10.6? Anybody else?
Yep.
Okay. Now, what exerts that force in the car? So here's my little car going around the track. Right, there's my little remote control car going around the track. Right? What exerts that force in the car?
The lever and the thing.
What keeps the car going around the circle?
Is it on a track?
Well, it's not on like a little. It's not like a little the trigger cars, you know. It's just a normal remote control car going around in a circle.
Why?
Right. What keeps it going in the circle?
The track. The person holding it.
Nope. What keeps us going around in the circle?
Centripetal force.
Centripetal force points that way. What's responsible for that centripetal force?
The track.
Battery. Friction. Alright, friction is what keeps that around the centripetal track.
Can we get the singers for singing away?
They already did it.
Oh,
Yeah. Did it yesterday. Okay. Alright, so what keeps that car going around the track is friction. Right? Does that make sense? Make sense? Alright, part C. A Viking wire swings a 0.1 kilogram rock in a 1.3 meter leather sling, completing a full rotation every 0.3 seconds. What is the tension of the leather sling? Alright, now, I know that these two problems, B and C, they give us both measurements and expect you to know some information about the situation. Alright, the 1.3 meter leather sling, that is the radius. Okay, if you have a question like that during a test or whatever, just ask. Let me know. I'll tell you what it is. So the radius is 1.3 meters, right? What else do we know about C? Mass. What's mass? Good, 0.1. So mass is 0.1 kilograms or 0.1 kilograms, right? What else do we know about this one? Time is 0.3 seconds. Now, what kind of time is that? It's a period, right? The period's 0.3 seconds. What else do we know? That he's a Viking, right? He has a cool helmet.
Yeah.
Right? Okay, so those three things. We need to figure out the force, right? Right? So this rock, here's my little rock in the sling, okay, is going around in a 1.3 meter circle, right? Right? If we need to figure out the force exerted, oops, right, see. If we need to figure out the force exerted, what things do I need to find? We have to find velocity. Good. How can I find velocity? So the first thing we need to do is we need to find v. Right? How can we find velocity? The first equation. Velocity equals 2 pi r over t, right? So what do I plug in? 1.3 is r, so 2 pi times 1.3 divided by 0.3. Perfect. So what does that equal? 27.2. Man, that Viking is getting that rock swinging around that circle, huh? Now what else do you have to find? And that's for acceleration or for force? What is the tension in the leather sling? So do we need acceleration?
Yes.
No. We just need what?
We need to find his phenomenon.
We need to find his force, right? We need to find centripetal force because centripetal force is the inward force exerted on that rock going around the other sling, right? So here's my wiffle ball, right? Right, here's my wiffle ball. Correct? Which way am I pulling on this wiffle ball? All directions. Towards which? Towards what, Kevin?
Middle.
Towards the middle. Towards my hand, right? Right? What supplies that pull?
You.
Me. I pull on the string pulls on the ball. So what is that?
Tension.
Tension, right? So the tension is what force? Force centripetal. The tension is our centripetal force. So we can use this equation 4, to figure out the force tension. Because the centripetal force is the force tension. Does that make sense, guys? Yeah. Okay. So the mass of the rock, very light rock.
Very.
Radius is 1.3. So we can figure out the force. What's the force he needs?
I thought the radius was 1. It's 56.
The radius is 1.3. How much is it?
It's 56.9.
56.9 newtons. Everybody agree, Kevin? Are there any questions? Can I guys talk about having a 1 kilogram rock instead? If I had a 1 kilogram rock, how much bigger would this force have to be? 10 times bigger? Yeah, it'd be 10 times bigger. It'd be 569 newtons. So would he be strong enough? Maybe. We'll see. I don't know. Vikings are pretty strong. All right.
That'd be enough to like.
I don't think so.
All
All right. Any questions? Any questions?